Score. This table shows the stats for my favorite basketball team. The input is the year, and the output is the total wins during the season. Click the button to send the inputs to the function machine to get the outputs.
No, I'm not finished.
Sweet, so this is the table we get from the function machine.
Wait, I know it's called a function machine, but how do we know that this table represents a function?
Right. In this case, the year is the input and the number of wins is the output. Each year has only one total number of wins. I get how this function machine is working now. We send in a year, like 2001, and the output that comes out is the number of wins in that year. If we change the year, the output automatically changes to the wins in that year. It's like the output depends on the input.
That's exactly it. That's why we call the input the independent variable and the output the dependent variable. Get it? Depend?
Got it. Inputs are independent variables and outputs are dependent. So for the next challenge, the perplexer says something about graphing. Do you think that means that you can tell from a graph if a relationship is a function?
Maybe.
Well, let's use the inputs and outputs in this table as coordinates for a graph. The first number is the independent variable, the year, and the second number is the dependent variable, the total wins for that year.
Don't stop. You put that movement on and it's bad to play. I don't know what connection I got going.
And on a graph, the independent variable goes on the x-axis. In our case, that's the year. And the dependent variable, or our total wins for the season, goes on the y-axis.
Ready to plot points? Click on each row in the table to plot the corresponding point on the coordinate plane. Click the button to plot the rest of the points. So what do you think about Gio's question? Can you tell from a graph if a relationship is a function? Yeah, check out this random graph. It's easy to see that this graph represents a function.
How do you know that?
The graph represents a function because each x value has one and only one y value. For example, when x is 4, y is 6. Here's another graph. What about this one? Well, on this graph, when x is 4, y is 2, 4, and 6.
This graph does not represent a function because at least one x value has multiple y values.
And that is way against the function rules. Let's check out what we've learned so far. A function is a rule that defines a relationship by assigning exactly one output to each input. The input is the independent variable and can be expressed as x. The output is the dependent variable and can be expressed as y.
That's why you won't be drinking them all.
Man,